Hello students, welcome to my YouTube channel MathematicsPoint. In our today's video, we will be learning about polynomials. So, first of all, we will talk about some basic terms and definitions. First is, what is a constant? A symbol which has a fixed numerical value is called a constant. Constants are generally our numerical numerals. For example, 2, 3, say -5, right? -7.5 or like √5. They all are constants. And what is a variable? A quantity which has no fixed value but takes various numerical values is called a variable. Variables are generally represented by letters or alphabets. For example, like X, Y, Z, like P, Q, R, etc. They all are variables. Right? Let us move ahead. Now we will talk about terms. What are the terms? Terms can be a constant, variable, or the product or quotient of number and variables. How? Let me tell you. Constant, first of all. If I talk about constant like 2, 2 is a constant, so it is a term. Right, -3/2, this is also a term. -1/7, this is also a term. Suppose if I write minus 0.75, this is also a term. Now, how variable can be a term? For example, if I write x, this is a variable and this is a single term. If I write minus p, this is also a term. If I write, say, q, this is also a term. Now, if I talk about product or quotient of constant and variable. Now, let me make you clear over here. Here, only product and quotient we can take, right? So, suppose if I take the product of 2 and x, so the term will become 2x. If I take the product of -3 and y, so it is -3y, so that is a term. Now quotient. Suppose if I take the quotient of, say, p over 3, this is also a term. Suppose if I write -5 over 6 q, this is also a term. So you can see in how many ways we can frame a term. It could be a constant only, it could be a variable only, it could be a product of or quotient of constant and variable. Now, let us move ahead. What is algebraic expression? What is that? An algebraic expression is a collection or combination of constant and variables of one or more terms which are separated by fundamental operations. What fundamental operations? Plus, minus, multiply, and divide. So how these operations help us to frame the algebraic expression? See, first of all, I am talking about the addition operation. Suppose if I take the addition of x and 2, the expression will become x plus 2. If I take the addition of y plus z minus, or you can say plus 7. This is also an algebraic expression, right? In this expression, there are two variables, y and z. Secondly, how I can frame algebraic expression with the operation of subtraction. Suppose if I take y minus 7 over 5. Now this is an algebraic expression. For example, if I write 2.5 minus r. Now this is also an algebraic expression. Now multiplication. Multiplication means product, right? So if I take the product of 2 and x, the expression will become 2x. If I take the product of minus 3 over 5 and m, the expression will become minus 3 over 5m, right? And divide. For example, if I take x divide by 2, this is an algebraic expression. Here I have divided the variable by the constant 2, right? Similarly, I can make like minus 3y divided by 7. This is also an algebraic expression, right? And we can also make algebraic expression by using multiple operations. How? For example, 2x minus 3y plus 1 over 5z. Here in this expression, 2x, this is the product of 2 and x. 3y, it is the product of 3 and y. Subtraction is also used. Addition is also used. And 1 over 5 z means z is divided by 5. So here all the four operations have been used. So this is also an example of the algebraic expression. Now let us talk about what is a polynomial. Let us come back here. In all these algebraic expression that I have framed over here, if you see the power of variable, here the power of variable is 1, here also 1, here also 1. So you can see in all these expressions, the power of the variable is a whole number. So any algebraic expression in which power of variable in each term is a whole number, we call it as a polynomial. For example, right, if I write x square minus 5x plus 7. In this expression, there are three terms. This is the first term, x square. This is the second term, minus 5x. This is the third term, that is 7. Now, in the first term, the variable is x. The power of x is 2, which is a whole number. In the second term, the power of x is 1, which is again a whole number. In the third term, there is no variable. So we can also write it like x raised to the power 0. 0 is also a whole number. So here, power of variable in each term is a whole number. So this is an example of a polynomial. Let us take one more example. Say if I write y cube minus 3 over 4 y to the power 5 plus 5.5 y to the power 8 minus 9. In this expression, only one variable, that is y, is used throughout. So here in the first term, the power of the variable y is 3, which is a whole number. In the second term, power of variable is 5, which is again a whole number. Here also, the power of variable is a whole number, that is 8. So in all the four terms, the power of variable is a whole number. So this is also an example of a polynomial. Let us understand it in a better way. Now here I will be writing the examples of the expressions which are polynomial. For example, if I write say xy square minus 5y plus 7. Here I have used two variables. The power of x is 1 and the power of y is 2. Both are whole numbers. Here the power of y is 1, which is also a whole number. So this is an example of the polynomial. Another example, like if I write root 3m square minus root 5n square plus 3. Here there are two variables here, m and n. Here the power of m is 2, which is a whole number, and power of n, which is 2, which is also a whole number. So this is also an example of a polynomial. Now let us give examples of expressions which are not a polynomial. For example, if I write 2 over 3 x minus 5 over x. Now, if you see it carefully, there are two terms. In the first term, the power of variable is 1, which is a whole number. But in the second expression, if I rewrite this expression 2 over 3x minus 5, if I take this x in the numerator, it will become x raised to the power minus 1. Minus 1 is not a whole number. So this is not an example of a polynomial. Let us consider one more example. Suppose if I write 3y square plus 5 root y minus 5. Here in the first term, the power of variable y is 2, which is a whole number. But in the second term, if I rewrite this expression, it will be 3y square plus 5. Now, square root of y means to say y raised to the power 1 over 2 minus 5. Now, 1 over 2 is not a whole number. So, this is not an example of a polynomial. Let us practice some questions. Which of the following expressions are polynomials in one variable and which are not? State the reason for your answer. Let us talk about the first one. 4x square minus 3x plus 7. Here in this expression there are three terms. 4x square minus 3x 7. In the first term, power of x is 2, which is a whole number. Here the power of x is 1, which is again a whole number. And the third one, which is a constant only. So we can say in each term, the power of variable is a whole number. So it is a polynomial, right? Let us talk about the second one. Look at the second one. It says y square plus square root of 2. Here there are only two terms, y square and root 2. The variable is y and its power is 2, which is a whole number, right? And in the second term, no variable is used. So it is purely a constant. That means in both the terms, the power of variable is a whole number. So we can repeat the same words. So this is also an example of a polynomial, right? Let us talk about the third one. So look at it. In the third one, what do we have? Here we have 3 square root of t plus t square root of 2. We can rewrite it as 3 square root of t means to say t raised to the power 1 over 2 plus t, here the power of t is 1, root of 2. Now, here lies a problem that power of t is 1 by 2, which is not a whole number. So we can write that power of variable in first term is not a whole number. So it is not a polynomial, right? Next one. Now, if we see the next one, number 4 part, the expression is y plus 2 over y, which we can rewrite it as y plus 2 y raised to the power minus 1. So look at the first term. The power of y is 1, which is a whole number. But here, the power of y is minus 1, which is not a whole number. So we can just write that power of variable in the second term is not a whole number. So it is also not a polynomial. Correct? Now come to the last part. That is x raised to the power of 10, y raised to the power of 3, t raised to the power of 50. In this expression, there are 3 variables and power of each variable is a whole number. But according to the question, we are supposed to check polynomials which are only in one variable. This, of course, is a polynomial, but it is in 3 different variables. So we can simply write that it is a polynomial in 3 variables, not in one variable. Correct? Not in one variable. So hope you understand about what exactly is a polynomial and what is not a polynomial. Thanks for watching the video. Hope you enjoyed it. Bye bye.